Hey guys, how's it going? In this video, I'm gonna go through this Leetcode 232 implement queue using stacks. So this is a easy type of question, but I don't think this is that easy. If you cannot figure out the idea, it kind of become difficult. So if you cannot figure out at the first try, so don't stress out. So this question was asked by Microsoft, Amazon, and other companies. So let's dive in to see what this is asking. As the name suggests, we need to implement a first in and first out queue using only two stacks. The implemented queue should support all the functionalities of a normal queue, which is push, peek, pop, and empty. And what they do is to let's take a look at it. So push is just as the name suggests, push the element to the queue. Pop is to pop it off from the top of the queue. Peek, just take a look at the front of the queue. Empty is check if that queue is empty or not. And so this is a constraint, right? So we must use a standard operation of a stack, which means only push to top, peek, and pop from top, size, and its empty operation are all valid. So and then I'll talk about some constraint about languages. Let's take a look at some example in here. So we given is such an input, my queue push, peek, pop, and empty. And so my queue just initialize the object, right? And then push, we push the first element, which is 1, and push the second element, which is 2. So now the queue looks like this. And then when we perform the peek operation, that returns the first element that push in, which is 1. When you pop it off, it pops off from the queue entirely. So compared to peek, the pop operation really remove the element. But peek does not remove any element, just look at it and as empty as the name suggests to check if the queue is empty or not. Okay, and also there's a follow-up which we will discuss later on. So it's a optimize. It's talk about optimization to see if the solution can be optimized or not, which we will discuss. So let's take a look at a standard approach to solve this problem. Let me show you the diagram that is really helpful to me. So let's say, so you will implement this using two stacks. Okay, so for example, let's look at the S1, which is the main stack, which actually represent a queue. So if there are already two elements in the queue, right? So 1 means that is the 1 is the element that inserted first, and 2 is the element that inserted second. Okay, and now what we need to do is insert the third element, which has a number of 3. So what do we need to do is to first and transfer the element from S1 to S2. So and then by using the standard stack operation, right? We pop it off one by one. So the first one pop off will stay at the bottom, right? So the 1 goes to the bottom of 2, and then the 2 will go on top of 1, right? So after we transfer element from S1 to S2, it looks like this. And now we insert the 3, which we go to the bottom of S1. And now we will bring back the element of S2 to S1. So after we bring it back, so we will be 1, 2, 3 again. So as you can see, by performing such operations, the 3 will be at the bottom, which is inserted at the latest. Okay, and this is again the step S1 is actually a queue, and S2 is the auxiliary stack to help us to transfer the elements across, and also at the same time when we transfer the element, and we will also reverse the order. So let's look at the implementation. So we in the init function we need to have two stacks. that we saw earlier, so S1 and S2. And also we have a helper function, I call it A to B, right? So while there's something in stack A, and then we will pop it off from stack A and append the element to stack B. So basically this is doing the transferring and also reversing. So basically we come back to this diagram, right? So this is the stack one, right? Let's say this is the A stack over here, right? And you have to transfer to a B stack. So while there's something in A stack, we pop off from the A stack and then append it to the B stack, right? This is exactly that, okay? And then at the same time, while we are transferring the elements, we are also reversing the order as well. So from 1, 2, the order of 1, 2, it becomes 2, 1, okay? So this is the push operation. This is the first step of the push operation, right? So we transferring from S1 to S2, and then we append. So now we have the room to append the new element to the bottom of S1. So this is what it does, right? So basically this is doing this operation over here. And after that, we have to bring back the element from S2 to S1. So we will use the same helper function, right? But we just have to go from S2 to S1. So basically it's going from 2 to here and then 1 to on top. So it becomes like this. And the pop and peak is pretty easy to understand, right? So pop, it just basically is standard stack operation, pop from the top. And the peak, just look at the last element. So in Python, we can use the -1 index and to check if the stack is empty. And what we can do is to check if the length is 0 or not. And it looks pretty efficient when I ran it, but now it's only 5.5%. But yeah, the number changes. When I ran it for the first time, it was 80%. So in terms of the time complexity, as you can see, it's gonna be, when we push it, it's gonna be big O of n. I think there's some illustration in here. So for the time complexity, it's going to be O n, and for the push operation is big O n. From the pop and peak, both of them is big O1. So now we can take a look at the follow-up question. Can you implement the queue such that each operation is amortized big O1 time complexity? In other words, performing n operations will take overall big O n time, even if one of these operations may take longer. So I found one of the solutions here is really helpful. Let's take a look at the diagram first. I think it's easier, and then we look at the implementation together. So for the second approach, right? What we can do is in the push operation, we just treat the stack one as a regular stack. Remember, we are doing it as a stack, so we don't see it as a queue as we were doing in the approach one. So whenever we append a new element, so we just append to the top. So in this operation, just take a BO1 operations, time complexity. And so when do we change the order? We change the order in the in the peak, pop or peak operation. Really doesn't matter actually. So if we do that, actually, the operation will amortize to be a big O1 time complexity. Let's look at the operation right now. So in this approach, right, for the push, we just push it to a S1. So S1 right now is actually a stack. Okay, so again, so the gist for the stack is the last in, first out. Okay, so we just keep appending to the top. And now when we do a pop or peak, so as you can see, the pop actually calls the peak. Because why we do that? Because actually when we call the peak, it transfers elements from S1 to S2. At the same time, when we're transferring the element, it also reversing the order as well. Okay, and the rest is pretty trivial, right? So basically, we return the element, or we just look at it, and also the empty, just check if the list is empty or not. So one thing I do want to emphasize, I think you kind of get it already, but I do want to iterate with the point. So again, S1 is actually in the second approach, S1 is actually a stack. As you can see, the last element, which is 3, appended at the top. And then when we call the pop or peak function, so we transfer the elements from S1 to S2, right? And after we transferring, becomes like this. Again, the reason why we transfer it because we have to reverse the order. And I think there is one sentence which was really key. Yeah, so here, the way the bottom element S1 will be positioned on top of S1, and we can simply pop it from stack 2, right? So in this case, stack 2 actually is a queue. So once S2 is empty, the algorithm transfer the data from S1 to S1 to S2 again, right? So this is the main difference between the approach 1 and approach 2. So in approach 1, S1 is actually a queue, and in approach 2, S2 is a queue. So so there you go. This is the two approaches to solve this problem. I hope that you find this helpful. If it is, please like and subscribe. And thanks for watching. See you in the next one. Bye bye.